Consider the relation R A, B, C, D, E and set of functional dependencies as F is equal to set of B gives CD, E gives F, D gives E, B gives A, AD gives B and F gives G. Calculate B plus, that is closure of B. Here relation with attributes A, B, C, D, E is given along with the functional dependency set. We have to calculate closure of attribute B. Here given FD set is B gives CD, E gives F, D gives E, B gives A, AD gives B and F gives G. This is the FD set given. We have to calculate closure of B. Closure of B is nothing but B. From B we can derive CD. From D we can derive E. From B we can also derive A. From E we can derive F, and from F we can derive G. So here closure of B is A, B, C, D, E, F, G. That is, we can derive all the attributes from B. So we can say B is one of the candidate keys. So here correct option is C. This question, a schedule which consists of two transactions T1 and T2 is given, and we have to identify the problem which is suffered by the given schedule. So here if we see the transaction, if we see the schedule, here T2 performs write operation on X and T1 also performs write operation on X. Here update on that item X made by T2 is lost. Why? Because if you see the schedule, here T1 is reading X and Y and performing some calculation, that is X. It is updating X to X plus Y and it is not writing that item X. After that, here T2 reading that item X and updating X as X plus Y and writing X. That is made by the update made by T2 is written by T2. After that, here T1 is writing data item X. That is, it is updating X as X plus Y. So here we can say that data item update on data item X is lost. So here this schedule is suffering from lost update problem. Lost update problem occurs when an update made by a transaction is lost due to an update made by another transaction. So here correct option is option A.
Following layer provides multiplexing or demultiplexing of packets. A. Network layer, a data link layer, physical layer, and none of this. So here multiplexing and demultiplexing will be done by the transport layer actually. So none of this is right answer, because it has to divide the things into different sub packets and again it has to recombine them. That is called demultiplexing. It will be done by the transport layer. Option D is the right option. Octal value of the binary number 11011011100 is. So here, so we need to group them into 3 bits each from right side onwards. So given number is this. So this is 3 bits. Again these 3 bits, these 3 bits. We have to put leftover bits zeros. So this will be 0113, 0113, 0113, 111004, 3334 base 8. Option A is the right option. Find the odd one out from the following in the context of protection. A. Access control list. B. Adjacency list. C. Capability list. C. Protection domain matrix. So access control list is the control list which will control the access rights. So it is related to implementation of the protection. And the capability list is for domains. Okay, this is also related to protection. And protection domain matrix is also related to protection. Adjacency list is not related to any protection. So B is odd. That means B is the right option here.
The asymptotic notation of the following recurrence relation is, here given recurrence relation is T of n is equal to 3 into T of n by 3 plus n by 2, and we have to express the given recurrence relation in asymptotic notations. To solve these kind of problems, we use Marshall's theorem. Here in Marshall's theorem, T of n is compared with A into T of n by b plus f of n. So here A is equal to 3 and b is equal to 3, and f of n is n by 2. So if we take case 1, we'll check if f of n is order of n power log a to the base b minus epsilon, where epsilon should be greater than 0. So this condition is verified. If this condition is satisfied, then T of n is theta of n power log a to the base b. So if we see here, f of n is n by 2 is order of n power log a, n power log 3 to the base 3 minus epsilon. So here epsilon should be greater than 0. So it is, if we simplify this, you will be getting n power log 3 to the base 3 means 1 minus epsilon, and epsilon is greater than 0 means this would be n by 2 is order of, this condition should be satisfied, but as here epsilon is greater than 0, this condition is not satisfied. So here case 1 is failed. So we'll go to case 2. In case 2, we'll check with if f of n is theta of n power log a to the base b into log n power k, where k is greater than or equal to 0. So if we simplify here, if we substitute values of a and b, then n by 2 is theta of n power log a to the log 3 to the base 3 log n power k. So if we substitute k is equal to 0, then this condition is satisfied. So when this condition is satisfied, we can write T of n as theta of n power log a to the base b log n power k plus 1. So if we simplify this, we would be getting, here we have taken k value as 0. So log k plus 1 will become log n. So this would be our theta of T of n is theta of n power log 3 to the base 3 means n power 1. So here we will be getting T of n as theta of n log n, which is option C.
Subnet mask with their corresponding number of hosts possible. This is P, Q, R, S. These are the hosts: 30, 62, 2, 14, 4 and 32. So 240 means how many ones we borrow from the host part? 1, 1, 1, 1, 0, 0, 0, 0. So using 4 bits, 2 power 4 minus 2, so it is around 14 are possible. So P is related to 4. 224 means 3 ones followed by 5 zeros. So 2 power 5 minus 2, so 30 hosts are possible. 220 means it is Q is related to 1. 192 means 1, 1, 0, 0, 0, 0, 0, 0. Total 6 zeros. That means 2 power 6 minus 2. 64 minus 2, it is 62. R is related to 2. 252 means 1, 1, 1, 1, 1, 1, 0, 0. So only 2 zeros. 2 power 2 minus 2. 4 minus 2. 2 hosts are possible. S is related to 3. Option A is right option.